Hello everyone, and thanks for this opportunity. And I really wish Ladybug Tools to keep thriving like this. This is a great platform for new generation architects where we can interact, we can design collaboratively. So let's start with this thing. So as an architect and as a design consultant also, we lot of times try to focus on integrated design. For example, we try to understand everything integratedly using Beam with such as ArchiCAD, Revit, which is also linked to Rhinoceros Grasshopper. So this actually help us to see the wider picture of in design practice, and also slowly it is becoming a mandatory practice for us in India also. After this particular three part of design analysis part, we are also focusing on interoperability between different tools in AC industry. And earlier in preliminary design phases, what we try to do was that we were using shoebox model. So with Ladybug tool, so it was a lot of loopholes were there for us, as the speed of simulation was totally depended on CPU configuration. A small part of a larger model was always visualized, not as a larger whole model in pre-design stage. Screen lock was a pure problem for us that particular time. Data storage and hard disks and hard drives can be very expensive for us sometimes. Sharing and interpreting can be troublesome among team members. But with the invent of pollination, a lot of changed for us also. So now we can analyze larger aspects of architectural designs using the cloud-based simulation using Grasshopper, and it has become faster, empowering faster design decisions. Now we can see a wider vision over variable zones quickly at same time. No interruption in design workflow. A screen remains unlocked whenever we are trying to simulate something. Data can be accessed anytime through web-based API. Sharing and interpreting data is also possible among consultants easily. So I will be sharing one of my experience with one of the model I'm using. This is an apartment model in which an architect had sent me for some simulation review and all this thing. And luckily we got the ArchiCAD model to test it out with pollination. So in the screen, you can see on the left-hand side, this is the ArchiCAD model where we used the properties of the walls, the windows, and the roof and the slabs. We brought it into the Grasshopper using the live some synchronization plugin of ArchiCAD Grasshopper, and then we applied the Grasshopper that honeybee data to the Grasshopper properties, and we came out with a single floor plate idea so that we could analyze the whole plate into one go. And this was also I was not expecting that this would be so fast. So approximately it was 7,000 sensor points for the one floor plate, and we created three recipes for that thing, because in ArchiCAD we have a limitation now. All the radiance based simulations are possible at a pre-design stage because we don't need a single line diagram model. But if you come into energy simulation aspect of ArchiCAD, so that still lacks some ready-made design philosophy to convert into a single line diagram. So a lot of times as a consultant, what we do, we try to start our design process with radiance based simulations using ArchiCAD, because it is directly interoperable between the interfaces. So in the annual edition, it only took 8 minutes to simulate 7,000 sensor points. This is really great. Then with the direct sun hour analysis, it took 6 minutes. And with annual daylight analysis, it took 9 minutes only. So as everything was running simultaneously, it took only 9 minutes for three type of simulations. So this was a great boost in our professional practice, in which we can see the larger aspect of a particular design in a very short period of time. This is a great help to the designers and architects to focus on lot of aspects in a design in a pre-design stage only. In the next step, we also try to understand with the multi simulation capability of pollination. We try to change the shading depth with shading angle of the shading devices, and we created almost 20 iterations for annual daylight and 20 iterations for direct sun hours. So once we completed the simulation, we created a GIF image where we could showcase the changes that we are having on both the aspect, because all in the pre-design stage, the direct sunlight analysis along with the direct solar radiation analysis with daylight analysis and with direct sun and hours can really help us to understand how much heat gain will be provided inside a building. So for 40 runs, considering 7,000 sensor for each simulation, approximately took us only 2 hours to simulate. But the best part of this is, once we have done with the simulations, all the data is present in the web API, which I can access anytime, anywhere if I have a Grasshopper tool in any of the system. So this is a great boost to check the designs anywhere, at any time, in any laptop or a desktop system. So we also try to understand different aspects through using the Energy Plus. We again created a model. Once we are finalized with the pre-design state, architect made a lot of changes with this thing, and they were very happy that we could provide them the data as early as possible. And we created an energy model with Grasshopper plugin, and we did an annual energy simulation with adaptive comfort also. So we were using 130 zones for a particular floor, and approximately took 1 hour 20 minutes, where adaptive comfort took 2 hours 10 minutes. So I want to highlight something here. What I learned from this particular exercise, particularly in radiance based simulations, the scalability of the project is very high. Like we can scale lot of sensor points easily. Like we can do a lot of simulations at a very faster speed because it scales very quickly. But in case of energy based simulations, the possibility of scalability is not there till now. What I understand till now, shoebox model is the only way to go for a preliminary design phase, because if you are going for any pre-design stage and you're already using radiance based simulations, then the scalability is very fast. But in case of energy, you need to wait till it actually completes in a single core. But the main plus point of running a simulation in cloud is that it doesn't stop you to make any changes in your design script while the simulation is running behind the screen. So that is one of the main plus point, like sending the simulation to the cloud. Then, but the concept of adaptive comfort in new Ladybug tools plugin has changed drastically, because it has been using now radiance also and energy plus simultaneously. So when we are using adaptive comfort in Pollination for larger models, the plus point of it is that the radiance simulation is being used for longer wavelength, to calculate longer wavelengths using multi-core, which is a very faster way to understand large setups. But in case of energy simulations, it takes a lot of time. So it took for this project, it took me almost 2 to 3 hours to understand, to calculate the adaptive thermal comfort model. So, but the main plus point of this phase is that everything is scalable right now and everything is available in the web API. But one demerit what I found in this particular aspect, but for now only, just because I know there will be more development to this thing. One thing is that whenever we are going for larger models, we should always consider that whenever we are downloading the data into the Grasshopper, it is also very heavy. So it can really lock your screen out, because I have crashed my system like I can't tell you more than 100 times because of this large data coming inside it. So I think when the web-based API will be ready to visualize the data on screen, will be a great possibility for us also. Then coming to one more simple project that I was working for a residential building, and we also did a lot of analysis in Pollination using annual radiance, direct sun hours, and it was really quick to do some and really interesting outputs we get with a lot of design phases. But the main idea was to understand how this adaptive thermal comfort model can help us to understand how the temperature changes in vertical grid pattern. So the main idea was to understand how we can optimize the roof angle, because in India we have lot of heat gains from the roof than the walls. So particularly want to understand how it is affecting the operative temperature, because this client was like a headache for me, because sometimes he will not understand anything, but once he sees this thing, and it has really helped us as an architect also to make the people understand how the things are working at a larger scale, because a superb model can't be visualized by a normal person in reality in that detail, but in with the visualization capability of Grasshopper with Pollination has increased our idea to communicate with the local community also. So this was the final review that I got. We finally used the EPS insulation over the roof slab, and we could generate lot of studies with that thing. And yeah, this is a great way to understand the VN simulation. So I think I completed a lot of things in a very faster way. So I can only just tell you at last, be simpler, faster, and productive. So thank you. Janki, up to you.
Thank you, Asis. That was great. So we're gonna open up to any questions from the audience, and you can totally just unmute yourself and ask a question if you have any questions for Asis and the process that he used. No, anyone from the team?
Yeah, I mean, I can start by asking a question.
Yeah.
And I think like other people can also type in if they want.
Yes.
They're not in a place to be able to really ask a question in microphone. So for the energy simulation, were you modeling like airflow network? Because for that size of model, 1 hour, 20 minutes also looks a little bit.
Yeah, you are right. I was using an airflow network model, and without airflow network model, I could simulate it in under 40 minutes. But with airflow network model, it really scale up to some 1 hour 30 minutes. Yeah.
Actually, I have another question about the energy simulation too. Did you need it such that the airflow could go across all 100+ zones in your model, or were there kind of sections that you think you might have been able to break down the model spatially? I guess if you wanted to parallelize it.
The model that I showed you, actually, when we converted into an energy model, it was a multi-zone model where we have almost 140 zones segregated, right? And when we actually, the main idea was to understand how the air temperature during humid period, during the rainy seasons, where the outdoor temperature is quite low, and we can induce some airflow current inside it. So the airflow network was a main important aspect for us, and we really wanted to understand how through the opening of doors to the opening of windows, each zones can be optimized. Yeah.
Gotcha. Yeah, I guess I just wanted to make also a recommendation that if you ever find a point where like each maybe unit of the building could be run as a separate model, that's like we have some recipes on Pollination, particularly the Dragonfly ones that try and parallelize the Energy Plus run through that.
Okay.
So that may be, I mean, yeah, you're correct that on its own, Energy Plus doesn't really have a parallelization capability, but yeah, but we do we have some workflows that try to spatially separate the model so that you can run it faster.
Sounds good.
I guess I guess one of the advantages, like one of the ways in which you can kind of parallelize your energy modeling is when you're doing parameter studies, because like if you're running, I don't know, 100 different design variations, let's say one of them takes an hour, which it would be quite unfeasible to wait 100 hours if you're just running it on one machine. Whereas if you run those all simultaneously, then technically it would still take an hour, right?
Yeah.
That's also true. Yeah.
Yes.
But definitely keen to see more. I don't know, maybe some examples of the stuff that you were talking about with Dragonfly in order to yeah, somehow parallelize a single energy simulation.
Yeah.
Yeah, maybe for next user meeting, we can do like we can have a recipe of the month.
Even I'm also trying with Dragonfly that using some safety tools also, trying to understand how we can bring that win factors into this particular UTCI comfort adaptive methods. So let's see how. I'm just trying it out. Yeah.
Okay. Well, I don't see any other questions, but I can ask a question. Asis, can you talk a little about getting started? Since we do have a couple of people on the call who have not started doing simulations, is there any pointers or suggestions or lessons learned that you can share?
Yeah. Particularly when I was a newbie in the energy simulation aspect and all this thing, the main idea was to understand the core engines, basically first the radiance, then the energy plus, because everything that we are trying to understand is through the engines only. So once you understand how a particular engine works, then it becomes far more easy for us to understand the workflow. So even understanding the ladybug tools first would be a great idea before diving into pollination. And yeah, that would be great.
Okay. And have you had a chance to use the Rhino plugin yet?
No, specifically not tried yet.
Okay.
Tomorrow I'll study. Yeah.
All right. Well, I see Antoine has added some notes for anyone on the call who is interested in the Dragonfly model to split or parallelize the energy simulation. And since there are no other questions, thank you so much, Asis, for sharing your work and giving the community some examples to look at. We're going to move on to Antonello and Mingbo, who are going to show us how to use the Rhino plugin.
Okay, I'm going to share my screen. Let me know if you can see the screen. Okay. You all can hear me well, right? You can hear me well, right? Okay. So, okay. Hi, everyone. So beginning of this week, we have released our Rhino plugin work in progress version. And how we design this plugin is not only for only exporting the geometry to another platform. So what we are trying to make a plugin available for you to editing the model directly inside the Rhino. You don't have to go jump between platforms and then exporting the models, which will probably we will know like it will often lose some data between while importing and exporting, right? So, and I guess in this meeting, a lot of our audience are already Ladybug Tools users. So probably I'm not going to show some like 101 tutorials. I'm going to show some highlights that typically is very hard to deal with in our other platforms. And so here I'm going to show adding a DOM to our current model and merge two rooms together. I'm not saying this one is like a typical zone model, a room model, a very complex model. So it's just an example to show you what if like something like this, not like typical box model, is has their own complex geometry. How do we do that inside the Rhino with our Rhino plugin? So I have add a generic Rhino BLab model here. So this is let me show you yeah, this view mode. So this is just a like dome here. So now my idea is how do I add this one to a room here? Let's say. So there are several steps, several work flows. But one thing I can show you is let's just make this one as a regular room first, we can just close this brep by using Rhino command cap. So it basically close this gap. Now I can just turn this dome to a temporary room first. Now we can say the command po add room. Yes, hit enter. Now this dome has been converted to a room. Let me just make a copy of this room. So if so all like regular Rhino commands like Gumbo, Control-C, Control-V, and Control-Z all works with our geometries. So in this case, I want to duplicate this one just for demo. Duplicate the room to a different location. I can hold out and drag this one to another location. So this will be duplicated, and all those child objects, it can also recognize its ownership of the room. This is all recognized correctly. And now let me move this dome, move to the top of the room, and then I can do scale. Okay, move. So probably this is a good place. Now I can use PO merge rooms. So now it will ask you to select the host room first. Basically, it will keep all the room properties as a host room. This is the host room, and then we can select the guest rooms. So this is a guest room. I can select multiple ones. So now I have only one. I just hit enter. Now this one is merged into this same the host room, and you can I guess you can select them by here as well. Let me turn off the roof. Yeah, walls, I guess. So you can see this area has been trimmed out, so the volume is physically connected. Now probably you can see here, so we don't have some panels. It's not like translate correctly as a roof type. Now it's the opportunity I can show you to select this roof, those geometries. I can do like selecting the geometry by holding Shift and Control here one by one inside Rhino, or I can select them inside this room manager here. So by selecting them all, okay, I have one more. So now all of them are selected. Now I want to change them to roof type and click OK. Now everything has been converted to the roof. So this is one way we can model the complex geometries, so we don't have to model all together in one at the beginning. And another one I want to show you is editing the geometry. So like I have one geometry here. So what if I want to edit the roof? I want to make it a tilted roof. So I still the same thing. I hold Control and Shift, select one edge of the roof. Let's say I want to move to 1 meter higher. So it changes the geometry here. So another case I want to show you is editing the child geometries. So once you select the room here, so it will automatically select all the child object that belongs to this room. In this case, all those surfaces, object, windows, and doors, and even from this side as well. And if you want to edit some child object here, we can double click it. So that's one case method. So double click the room, it will entering the it enters this editing mode. Now we can change the geometry. Let's say for energy simulation, probably we don't need so many room apertures here. We just need to merge them into one. Let's say it will increase the simulation. And double click or hit escape, and then it exits the editing. Another way we can click the room, turn on and off room selection, the toggle here. So once it's off, now you can freely select any child object directly. Now I can turn on. Okay, and I guess that's all I want to show you here. So next step, Antonello will show you how to bring in this Rhino model to the Grasshopper or using script to automate some steps.
Thank you, Mingbo.
Okay.
Okay, can you see the screen? I don't
Yes.
see.
Yes.
Ah,
Yes,
okay,
we can see
thank
the
you.
screen.
Thank you for the feedback. Okay, yeah, one of the features that we have in Pollination Rhino is how I can take data from Rhino and move this data inside Grasshopper. Maybe, for example, you can use part of the Honeybee script to change the room, for example. And after your changes, you can go back to Pollination Rhino with a bake function, with bake functionality. So, for example, I want to add some louvers here, and I want to do it dynamically. For example, using the component from Honeybee of louver shades. And we can do it with Grasshopper also. So if I open Grasshopper and you go to Honeybee tab, you can see that there is a new subcategory, Rhino. Here you can find the component let you exchange data from Pollination Rhino to Honeybee and from Honeybee to Pollination Rhino. In this case, I want to change just one room, for example. So I move this pollination room component in the canvas. And if you right-click on it, the usability is similar to the param. I can select pollination room. So for example, I select this pollination room here. Let me enable just the view that show you that this one is pollination room. Okay, here we go. I already selected this one here. And if I check with the panel, my room is correctly translated to Honeybee room. It means that, starting from this point, I can continue to edit this room using only Honeybee instead of using Pollination Rhino. For example, I can change the geometry. So let me add some louver shades, for example. And I connect this Honeybee room here. I type one of the depth that I have in mind. And I can use also slider to change the shade count if I want to use this method here. Let me use shade count. Let's set up to 40. And because this one it's a Honeybee entity, I can also use the preview from Honeybee in this way here. So in this case, yeah, I can easily move and check what's going on inside Rhino as well. Okay, and I can also change the property, as I told you. For example, if this one is an office, for example, I want to apply some LED instead of the current one. If I'm not wrong, it's Open Office one. So if I double click on it and I go on load, you can check, you can check the property of the room. And in this case, the lighting, it's reading the program type that I have inside. And the program type that I have inside, it's a small open office. So I assume there is a Dashrai data inside, and I have some classical lighting system for the open office. I want to replace my current one with a new one. So I can use Honeybee Energy, and I can replace the value that I have, for example, that from my light designer. So let's suppose that I have some LED inside, and I replace with 6. Okay, so in this part, I replaced part of the geometry. I added some louver shades. In this part here, I'm changing the lighting system. And now I'm ready to go back to Pollination Rhino. So I can use another Pollination room component. But this time, I use it just for the baking part. So bake Pollination room. And I'm bringing everything from Honeybee inside Pollination. And if you check this one, it's a Honeybee room now. It's a Pollination room now. Okay. Yeah, let me show you just that this one is a room. Let me activate the Gumball. Okay, yeah. This one it's a native one. This one it's the new one. And if I double click on it, you can see that in under loads, I have my data in. So I have 6 watt per meter square in this case, instead of the native one, which is 10. Let me Control Z, and I can delete, obviously, the new room that I updated. Okay, let me disable temporarily the preview of Honeybee. And yeah, we support also the scripting part. So it means that if you have in mind some strange feature that you cannot find in a current plugin, you can use or DLL to create some crazy script for automatization, let's say. Let me, for example, I want to change the window wear ratio of the same room because I see that there is enough glass here. So I want to have, I want to change the amount of glass that I have on this facade.
Antonello,
So yes.
Before you go into the scripting, we have 2 questions about the workflow that you just showed. So do you mind if we just answer those questions? Oh, it looks like Mustafa's answering. Oh, he answered one of them, but there's a question. When you bring the new room from Grasshopper, do you need to recalculate adjacencies? Oh, Mustafa answered it. But yes.
Yeah, if you have just one room, you don't need it. If you have many rooms, for now you have to recalculate them because you should, yeah, you should recalculate to solve the adjacencies again. Yeah, this is the only. Yeah. Sorry.
So it's basically a reference. It's a reference. Whatever you have in originally inside Rhino, it will keep everything same. If you want to change it, so you have to do it inside Grasshopper, right?
So what I'm hearing here, I think, is just like the people want to just if it's the same room, I'm modifying and geometry is not changing, or even if that's changing, instead of making a new room, if we have the ID, there should be an option to say, you know, update the current room. So it means basically you remove it and copy the new one with the same name, so they don't have, you know, like something like adjacency and all that kind of stuff. But right now, yes, it will be a new room, so you have to redo it. If it has adjacency with other faces, then you have to redo it. It keeps all the information that comes from the original room, of course.
Yes, the ID is different. And this is the reason why you need to solve again the adjacency. But thanks for the feedback. Okay, the other option is about the scripting part. So you have the possibility to type directly your Python script. And here I have 2 examples of Python script. Obviously, you are free here. So the only thing that you need to know a bit SDK, and need a little bit of documentation about the classes. But after that, you can start by yourself. For example, you can add also some interface with Ito as you want. This one, for example, is a small script to create a report about the room that I have in a canvas. So if I run it, it shows me room by room, for example, the info that you have inside Honeybee. So I can, for example, check that OpenOffice has this area here, has this volume here, the exposed area is like this. And you can export. Obviously, here you are free. You can export with using the CSV format as you want. You can customize the script. Or there, you can create script to change, for example, the geometry. And this is, for example, the script that you can use to modify the room, the window wall ratio of the facade of the status of room. Let me try the script. And I select the room that I want to change. And I press enter. And this one is just a script. So I can change, for example, the north side. Let's see. Yeah, let's select 20, for example. The south side, 35. And the west side, 25. And click on change it. So it changed the glass. And because here, for example, I have this strange shape of the face, you can see that the windows is not really clean. So we can use the power of the tool of the Pollination Rhino to change the face easily, because we support the split face command. So if I type the command split face, I can select the face to split. In this case, is this one. And I can split this face directly. So from here to here. Now I'm sure that if I run again the command, the windows looks really nice. And you can also merge them. For example, look at here. You have 3 different faces. You can use a merge face command. So this one and this one. And again, this one and this one. And you can clean your model easily using Pollination Rhino. So let's try now the script again. So Python, edit Python, run it, select this good guy here, and let's resize 25, 40, and 25. Change it. Let's check again. And here we go. Okay. Yep.
Okay, that was awesome. We had a couple of questions that Mustafa kind of answered, but if there are any questions again, we'll.
I think Leland had a question. He raised his hand.
Oh, gotcha. Okay, Leland, you can unmute yourself and.
I think my question was answered in the script. I was just curious about exactly how things were modeled. It seems that these are all based on zones and like as solid zones. So when you put them together, you have overlapping single planes. And the only reason I was asking is I was just thinking about the workflow for translating existing models into daylighting and energy models. And I know that we often don't model all the rooms completely. So I was just trying to think of how this is going to work and what we would need to do to say a building that might have interior walls that have thickness and trying to translate them down to actual rooms. So I was just a little curious, but I do think once we start modeling as solids, all of this gets very, very smooth.
So you don't have to if you're doing it for daylighting, or you want to do mix of energy and daylight. So we have the rooms, but there is another tab you can have orphan faces. Basically, you can have a mix of faces and rooms.
Very cool.
So you can just have a model with only like faces, which you can use for all the daylight radiation studies. As soon as you want to do energy plus based or room-based studies, then you have to have the closed rooms.
That makes a lot of sense.
So in the chat box, we shared a bunch of resources that we have to get you started with the Rhino plugin. We do have a user manual and a YouTube channel that kind of corresponds to the user manual. And there's also on GitHub a bunch of sample scripts that include the one that Antonello just showed. Any questions? We've got a quiet audience today.
And it doesn't need to be, I think, related to the Rhino plugin. Yeah. Any questions, comments about pollination in general? Anything that we can do? We just heard about the viewer and how important is that, and we are working on that. Anything else on your list?
Mustafa, do we have a direct integration possibilities with the Design Explorer and Honey Pollination?
Right. So it has come up a couple of times on the forum, and as we speak, actually, we have an ongoing conversation internally about how to do it. There will be one there. There are questions to be answered, about like how we, for example, retrieve the results from a text file if you only want one, or how do we generate the images? Is it part of the recipe that you run, or is it something that you basically select these items and say, I want from this result to be visualized, I want to see the images in 3D models. So the whole technology is there. We have built everything to make that happen, but we don't have it. So the short answer is yes. The reason I actually brought this thing up is to show this to the question that Leland had. So you can see here, there are like, right now we are using it for shade objects, but here is all the rooms that you have, and then you have all the orphan faces that can be shade or other faces that are not part of a room. And Asis, did I answer your question?
Yeah, you did. Yeah.
Anything else? Okay, I know like some people are asking about the Revit plugin outside, but like if you're watching this video afterwards, so again, like last time we said between the last one and this one, we will release the Rhino plugin, and we did. This time between this one and the next one, we might release the WIP version of the Revit plugin. I'm not going to promise 100%, but that's what we are working towards. So we are reworking the user interface now at how we have it in Revit. And again, meanwhile, I know like there are issues with sharing Revit models, and it's hard, but some offices has already helped us. Thank you so much. If you want us to sign something to have access to Revit model, we are open to that. And we are not going to share it with public. This is just to make sure the script will work for the way you model your models, or at least we have an idea how you do it and provide some feedback of like, if you do it like this, it will work much better with our Revit plugin.
Okay. There was, so Asis is asking, any future plans for Butterfly?
So that one is in the long future. We started a collaboration with another company, which I'm not going to name because, like, I don't know if I can, to use their capabilities for running CFD simulations from inside Pollination. So it will be like additional functions that comes with a plugin. If that happens, that will most likely happen sooner than Butterfly.
Yeah. I mean, that's the intent of Pollination, right? Is to collaborate with other developers and provide a product that is a one-stop solution that's not necessarily just Pollination, but it's like a central node. Yeah.
Yes, that's very true. Basically, we are building the platform so you can use the best products out there, and there will be naturally at some point there will be multiple options that you have to do the same thing, and that will be your choice of like which one fits the best for your workflow or for your recipe, and then you can use that. That's the goal.
Hey, Mustafa, I have a question for the Butterfly. Is that something that you're gonna have to subscribe to the other platform to get access to it, or is it gonna be?
Yeah, I probably should have not said that, but that's another. Let's us do the integration, and then I think for now, at least for the first iteration, to keep it simple, we will work with companies who already either have access or like they're willing to have access to their platform. I can't speak on their behalf, but I know that because it can get complicated, we are not going to be the ones to just like take on the charge, at least for the first iteration.
Got it. All right, sounds good.
Any word on a clean output from Gbxml, ISVE. So again, as I said, like that comes with the Revit plugin. You can already, with the Rhino plugin, you can already export Gbxml and show it in IES if you want, or any other software that accepts Gbxml.
Export and import.
And import, yes.
Yeah.
Yeah, and we have in the user manual a section that talks about all of the different formats that the Rhino plugin can import and export to.
But if there is no other question, I can just show it here quickly. So it basically what the Rhino plugin does, it adds this import and export natively to Rhino. So now if you go and do save as and check here, you will see there is green building XML, which is XML. Then you have HBJSON, which comes with it. Then you have IDF OSM somewhere. Oh, I can't see, oh here, OSM that also generates IDF. So you can directly go from Rhino to any of these three platforms, and they're all coming when you have Rhino plugin installed. It basically adds these export functionalities. It also adds the import functionalities, or you can also do it when you open a file now. Here, if you check your file formats, there is green building XML. Here, there should be Open Studio OSM. And also there is HBJSON too. Yeah. And one thing that we didn't talk about is when you create your model like this, you can save it as a Rhino file, as a Rhino 3DM file, and all your information will be inside that 3DM file. So you don't have to save to HBJSON back and forth or Gbxml. You can just have a native Rhino file, which has all the information that comes with the Rhino plugin. I mean, the way I like to call it is it basically changes Rhino to a full-fledged building simulation UI, user interface.
And we plan to add more features to it, right, in the future releases, things like sun path and shadow studies, some of the features from the tools.
Correct. Like, so Abraham, I saw your question and I answered that, but the next steps are, one, we are working to make running a simulation experience better from inside the Rhino plugin. We are adding the local run, as well as we are making it easier to run it on Pollination if you want. The other step that in parallel we are working on is basically bringing the Ladybug parts of Ladybug tools to Pollination Rhino plugin. So things like SunPath, windrows, and you should be able to run quicker studies, but that will take time, so it will be one by one. Back to your question, Abraham, the geometry is not duplicated. It's only one Rhino geometry. So if I turn off the preview here, you will see this is just like a native Rhino geometry that you have. It's you don't have to duplicate it. It's basically this. We use the same Rhino model. We add metadata to it.
So if you delete a Rhino, like a pollination room, it deletes the Rhino geometry as well.
Right. Correct. And you can delete it, and you can Control Z, and everything comes back with all the information. I mean, I know this is in Rhino world. It doesn't make any. It's not something new, but like in building simulation world, this is something very, very great that's happening in a 3D environment.
Okay.
Okay.
Any last questions? We have 3 minutes left. Nope.
Okay.
Okay. So if there are no other questions, we're trying to keep the user meetup schedule for the fourth week of every month. So the next one will probably be August. So it's the fourth Thursday of each month. So August 26th, just to put it on your calendar, and we'll send out an Eventbrite or a discourse post signaling it. And hopefully we have the Revit plugin to talk about. And if anyone has any project examples that they want to share with the users, I'd love to hear from you. Just send me an email. All right. Thank you.
Yeah. Thank you all, and take care. See you soon.
Thank you.